All right, another example problem. This is problem 3-32.E. So on page 116 and then the figures on the next page. A cylindrical steel bar is attached at the top and is subjected to 3 axial forces as shown in figure P3-32. Its cross-section has an area of 1/2 inch squared. Determine the deflection of the free end. Okay. Excuse me. All right, the deflection, in the interest of time, I'm going to hurry through this. The deflection at the top section, we don't have any point names, no. Okay, so in the 25-inch section, the deflection due to the loads is going to be, again, FL over EA, right? A is the same in all of them. In fact, why don't we do this? Why don't we calculate the deflection in the upper section and the next two and just add them all together at once, because a lot of these will factor out. In fact, the E and the A will factor out in all of them. But anyway, let's write it out and then we'll see what we've got. This pen's not working. The force in section, well, the 25-inch section, you guys can see it there. How much force is in that section? An easy answer, all of it, right? All of it. The 3,500 plus the 2,000 plus the 5,000. So we'll write out more detail here. Let's see, can we do that in our heads quickly? 7, yeah, that's 10,500 pounds, isn't it? Yep. Mm-hmm. The length of that section is 25 inches. E, did they say this was steel? Yeah, is it rectangular or round? Cylindrical, okay. So 10 to the 7th power pounds force per square inch, that's just 10 times 10 to the 6th. Okay, that's the elastic modulus for steel. And then the area is 1/2 square inch, okay? Let's not calculate that deflection yet, because what we want to do is add the deflection for all 3 of the sections, okay? So for the next section, which is the 15-inch section, we can calculate its deflection. Let's put a subscript 25 and a subscript 15 here so you can differentiate them. It's just going to be FL over EA, but notice that the forces applied to that 15-inch section are just 2,000 plus 5,000, 7,000 pounds. Does that make sense? So 7 kilopounds. And the length of that section is 15 inches divided by 10 to the 7th, of course, PSI, I'll write it quick, times 1/2 inch squared. You see how the denominator is going to be the same for all of these, okay? For the 10-inch section, FL over EA is going to be, let's see, well that force is just 5,000 pounds, because that's all the force in that section, right? The 2,000 pound force and the 3,500 pound force occur in the other sections, but not in this one. So 5,000 pounds force times 10 inches over, same thing we had before. Now we really want the entire deflection of the free end. So what we really have to do is just add up the deflection from each of these sections. Okay? And I already said that the E and the A will factor out. So all we need is 10,500 times 25 plus 7,000 times 15 plus 5,000 times 10 divided by 10 to the 7th and divided by 1/2. Now let's be careful here. I haven't written any units in. This is bad practice, and I've done it because I don't have space on the board. Let's see what units we should get. Pounds force will go away, inches squared will go away, and we'll have inches of deflection, which is what we would expect, okay? All right, so I need help. 10,500 times 25 plus 7,000 times 15 plus 5,000 times 10 is how much? Let's write down the intermediate results so that we can hopefully not make a mistake. So 10,500 times 25 plus 7,000 times 15 plus 5,000 times 10, basically plus 50,000.
405,000.
405,000. I'll go ahead and write the units up here since I have the space for the numerator. Anyone agree with that? One second, 405,000? Well, I'll work on the next part. Let's see, this would be 5 times 10 to the 6th, and the units are pounds force. Because this is pounds force per square inch, this is square inches, so I'll just be left with pounds force in the denominator. And I took a 10 out of this, multiplied it by half, that's how I got the 5, times 10 to the 6th, what we're left.
I got 417,500.
Second that.
417? Okay, thank you. Okay, so we'll get rid of the pounds force again. So now we need 417,000 divided by 5 times 10 to the 6th, basically 5 million. That's gonna be roughly, what, a tenth? Yep. 0.08 inches. This is about a tenth. Okay, that seems reasonable. What I did, if you're wondering how I said we've got an answer that's close, I just looked at 500,000 divided by a million. So just off by a factor of 10. Okay. So there's the deflection of the free end, 80,000 of an inch. Is that acceptable? I don't know, depends on what this is for. But that's how much it's gonna stretch given these loads. Make sense? Questions? All right, I will post another homework set that I want to keep due a week from today. It will be from chapter 3. I have not worked all the example problems I want to work because we have not talked about stretching yet.